Alright, so this is my project, which is a lab workflow management tool called Watchtower. So now, why did I build this? After doing some research with in the lab and after speaking to some lab researchers, I found out that there's actually one very big problem which hasn't been solved, and that is the problem of tracking and journaling. So ideally, in the lab, researchers generally have the concept of a lab notebook where they write down their observations and data, etc. The problem is that there isn't any way to connect that observation with the artifacts relating to that observation. So, for example, when a researcher is working on a specific experiment right now, which consists of a couple of test tubes he's working on, he writes down an observation. There is actually no way to connect that specific test tube or a bunch of test tubes with that observation. So when he goes back and reads those observations again at a later time, or when he comes across those test tubes again at a later time, there is no way to connect both of them, which causes a big problem actually, because you just end up with a bunch of test tubes which are unaccounted for. Like, you know where they came from, but you don't know what the observations for them were and like what they led to. So this was the problem that I tried to solve with this with Watchtower. I feel like I took the first step in solving that problem, in that I have a good groundwork to tackle that problem, but by no means is it finished. So as I said, these were the points by for which I made this. So the way I like to describe this project is that it is actually a source version control for biology. So you see what source control like GitHub, what it does is that it saves a copy of your project, and it saves it within a larger framework of the entire project. So it saves the immediate file, and you have an idea of what the entire project as a whole is, because you can go up and down, in that project, and you can see what the file before it was and what the file after it was in the directories above it and the directories below it. And also you can commit the same file again and again, so it also tracks which version of the file you're working on right now. In the head, it has the latest version, and it has the mistakes you made in the previous version or the changes you made in the previous versions. So by using GitHub, I could actually reuse the code that they use and reuse their methodologies, and basically make another layer on top of it for catering to biologists and catering to a more lab researcher community. So I'm gonna walk you through the project. Just to give you an idea, this is what the architecture looks like. So you have a thin authentication layer over here. So when a user signs in or logs in, the data is authenticated, wherein it is checked if the user exists before, if the password has existed before, if the credentials are correct, and if all of that checks in, then he can head over to the profile page where he can actually manage his project, add more files, delete files, and edit files, commit to existing files, etc., etc. All the metadata for this information about which user has which project has which file, and where this file is stored, what the ID for that file is. All of that data is stored on a MongoDB database. I chose MongoDB because it is schema-less. It's a NoSQL database. So in the future, when I want to extend the functionality by adding more features, storing more data, for example, or even reducing it data, I can do that without having to redraw tables, which I would do in a SQL database. Also, I'm utilizing GitHub, as I said before. So obviously, I'm using that database as well, which is the GitHub application. I access it through the API which they have, which is pretty user friendly for the most part. It does get a little hard to do complex actions, but I feel like it's a good design option to use GitHub for this. So let's walk through the application. So I have on my terminal a MongoDB instance running over here, um, and I'm gonna run my node server on it. So let me just go and start the server. So it's listening, and let's go ahead and refresh this page. So as you can see, you have two options. You can log in or you can sign up. For the sake of this video, let's sign up a new user. So I'm a biologist. I want to use this feature. So let's sign up. So let's do sample user one, password, and sign up. All right. So it takes me to the profile page. Just as I go through, I'll keep showing you how the database changes as and when I make the actions. So I have two collections. I have collection one, which is projects, and collection two, which is users. So users actually stores the user information, which is the password and the login information, whereas the project stores a bunch of data relating to the projects that the user has. So if it's test user one, he has an array called all work, which stores all the projects that he has in that thing. So yeah, so we just created a user. So let's look for that user. It was sample user one. Okay, was it the sample user one? Yes, it was sample user one. Oh, I gotta refresh it first. I'm sorry. Sample user one. Yep. So there he is. As you can see, the password itself is hashed. So I change the salt every couple of days, and the password is hashed and stored in the database, and so is the user ID. Yeah. So let us create a project. Let's do sample project one. Create, and the project is created. How do we know? Let's check the database. Let me refresh this guy. Sample project, and I have sample project under sample user. That's the first project. Let's create another project. And the project was created successfully. Let's check this guy again. Refresh, and sample project 2. So as you can see in the all work array, you have two projects, sample project 1 and sample project 2. Alright, so I can see which projects are listed under my name by browsing through projects. So I can browse through these two projects. Um, so this first half of the page is where I actually create projects and browse through the projects. To actually work on the projects, I need to load them by pressing load, and then down here would be where I would actually be able to operate on them. So all the functionality of the application is in the box below here. So to get the application down here, I need to load it. So let's go ahead and load sample project 1. So sample project 1 is loaded now. Um, I'll just run you down through all the operations in this part of the page. So you have the head over here. What does the head do? So the head actually tracks the project and it points you towards the latest directory in the project. So that's telling you what the last step was, what the last directory was. So I'm a biologist. I come into the lab, I start a new project. So it's telling me that you've only created a project. You haven't created any directories under this project. You haven't created any files under this project. You only have a base for the entire project. So let's go ahead and extend this head to a new directory or a new step. So I have a project and I want to I want to do step 1 on this project, whatever that may be. um, Step 1 on this project. So let's extend this project to step 1. So now the head is pointing towards step 1. D signifying directory, and this whole bar pointing towards the latest step, the last step that I did. Now, for this step, I'm working with bunch of artifacts. Let's call them 5 test tubes. I'm working with 5 test tubes in this project. They can be anything for that matter, but just for the ease of example, I'm going to give 5 test tubes. So now I want to store observations for each of those 5 test tubes, right? Because I'm gonna do some experiments on them, and I want to they'll yield some observation, they'll yield some results, and I want to observe these results. So I want 5 specific text files which I can relate to with those 5 test tubes, right? So now how I do that is I just copy the path to the path part. I create a document name. I can keep this document of the bacteria I'm working on, or anything for that matter, so BCG. And I'm working with 5 samples, right? So I want 5 different text files, which I can edit later on. So let me just add these guys, and apparently it has created them. So if I log into my console, I can see over here what actually happened when I pressed create, it gave each individual file an ID, which is over here. What this ID is, it's a UUID, which is a ID composed of my MAC address and the timestamp, so it always is unique. Each text file gets a unique ID, and that text file is committed to the GitHub repository by that ID. Now, what that does is that it makes each file individually indexed. So when 6 months down the line, when I want to reference a file, this ID is actually printed out and stuck on the test tube. So when I find the test tube 6 months later and I want to reference this file by this ID, I just go in and search by this ID, and I get all the text file with all the observations for that test tube. Um, so for now, let's just go into GitHub and see if where these files are. So this is the test repository I'm using for now, which can obviously be changed later on. So we created sample project 1. Indeed, it's over here with the 5 files that we created. So we have BCG 1, 2, 3, 4, 5 representing the 5 test tubes I'm working on. So let's do BCG 1. It shows the commit message as the ID of the sample, which is the ID I'm going to print out and stick on the test tube, which this represents. So I can go in here and edit this file. So let's just do observation 1, which is this sample contains XX percentage of YY. I don't know, whatever biologists like observing. So similarly, I can have a bunch of other observations. And what I do is when I'm done writing down my observations for that test tube, I just copy the code, the unique code, and commit this with that same code so that the commit message is maintained for all the commits. So I've committed this, and now it exists over here with the new updated version of this. What I can do later on, so 6 months go by, right? I have found a test tube with this ID, and I want to find out what my observations for that test tube were, right? So what I do is I have the ID number because it's written on the test tube. So I can just go in and search for it using the thousands of third-party applications which are available to search through GitHub repositories by commit messages. This is the one I like to use, which is made by This Is CatCat. You can find it on this link. So I have the repository name that I'm using. I have the username that I'm using. I have the repository name that I'm using, and let me just go in and copy the ID that I found on the test tube, right, and search for it. So as you see, it yielded 2 results. Let's check out the latest one. So it's showing me the entire history over here. If any one of you are familiar with GitHub, this is one of the really cool features of GitHub, that it shows me what I changed with every commit. So it's telling me that I added this line over here and I added these lines over here in this commit. All right, that's helpful. But I want to know what was the commit before that? Like, what did I change? So let's go to the commit before that. And it tells me, well, before that, you only had one line, which was this. So it's obvious that I added those lines in my next commit, which, which are helpful. So now I'm done with step one, right? I've gotten done with step one. I have my step one carried out. I have my results. Now with those results, I want to I want to go towards step two of my experiment, which may be some other bunch of things that I want to do and get results for. So let's extend this application to step two, right? Because step one is done. Step two, extend, boom. So now you see the head is automatically updated to step two. Just so you know, this is not only the front end, but this head is being maintained in the back end as well. So if I go in here and refresh and search again for sample project, um, sample project, was it two or one? All right, sample project one, and you can see the head is being maintained in the back end, right? So this is a pretty stable solution. So this is telling me in essentially that my last step was step two. This is the next progressive step in this experiment. And supposing now I'm working with three different artifacts. For the sake of simplicity, let's consider I'm using three test tubes in this step, right? So what I do is I just copy this path, paste it over here. Now because I want a way to reference those three test tubes, because I want to write three specific observations for each of those three test tubes for a later time. Um, so let's name these test tubes by the code name of the bacteria or the chemical name, whatever it may be. Let's call it EWQ. And I want to make three samples because I want to make three text files because I have three different samples. So let's add these guys. Alright, so it's telling me that my document has been created. So let's check it out in what's happening on the console. So what's happening on the console is like before, it created three different text files with EWQ1, EWQ2, EWQ3 with three individual IDs, right? It also committed like before with these IDs. So let's go and check out GitHub to see if Watchtower is lying or if it actually did that. So so let's go back to my home repository. Sample project one is what we created. Step one was these three files which we worked on, and let's do step two because as you can see, a new step two directory has been created, and a step two file is also being created to tell you what step two directory actually means, what step was it, and you have three individual text files representing the three test tubes I was working with in step in step two. So I can go ahead and edit these files. So let's edit EWQ1 and let's say something about it. Let's see. Let's write node. This file is a child of let's do BCG1, right? So I use the contents of BCG1 to make this file, right? Then I can write observations about this file. This sample contains I don't know, pp percentage of QQ, and similarly have a bunch of different observations. And like before, I just copy the the commit ID and save it, commit this. Along with that, I also print out this commit ID, which and print it out and stick it on the test tube I was referencing this by, right? So now not only do I have a lab notebook functionality over here where I'm writing down the information that I need, I also have a way of referencing it to the test tube I'm using. Along with that, I also have a very neat progression of steps that I used for that project. So I know that step 2 came from step 1. I know that EWQ, W2, 3 came from BCG1, 2, 3. So this information probably wasn't um, easily accessible before. I know for a fact that it was not a very easy thing to do earlier, which becomes a lot more easier using Watchtower. Not only is it easily organized, it's also very easy to use because you only have a bunch of functionality, so you really can't go wrong with this. It also solves a very big problem that it creates um, any number of files for you at a go. So I can do 50 files if I want to, because I have 50 different samples, and it'll do that. All I have to do is just go in and edit the ones I really want to track. So just as a test again, let's just go and assume that someone in the lab 2 years down the line found a sample with this ID stuck on it. And he wants to find out what the hell that is, right? So he goes into the test repository for that lab and just copies this down, the ID which he found in the test tube, and searches for it. Boom. He has the ID for that, and it tells you the information. So for this, we didn't store any information. We actually stored for EWQ1. So let's just copy this ID to see how it would be in the real world. Yep. Just copy it down here. Boom. So you see, this was the latest commit to this file, um, and it's telling me that this I wrote down at that 6 months ago or 2 years ago that this child, this sample was a child of BCG1. Oh, what is BCG1? I don't know what BCG1 is. How can I find out? I can find out because I know which the directory of this file. I know that it's in step 2. So all I need to do is just go back. Sorry, go to my GitHub repository. I know that BCG1 existed in step 2, and it's telling me it's a child of BCG. It's telling me that it's a child of BCG1. So obviously, if it's a child, BCG1 is in its parent directory, and which is D step 1, and its BCG1 is right here. Is how I would find how that sample came into existence. Um, as you notice, like when the experiment grows really big and hairy and is long, has a bunch of directories inside each other, this actually solves a very big problem. It tracks each and every test tube that is important to you. It tells you where it came from, and it's telling you what happened after it. So I solved the main problem that I was set out to solve, which was somehow making a glue between tracking and observing information. If I have to do a failure analysis of this, I would say probably the biggest failure for me was the GUI that I created for this. I made a very big blunder of actually trying to make a GUI before making the functionality. So I went ahead and I wanted to actually track all of this in a visual way to show people visually what is happening. The problem with that was I went ahead and created a GUI without actually adding any functionality. So when the time came to actually add the functions to that GUI, things started to break very fast, and it just became one huge ball of mess, right? So I had to scrap all the entire plan and take this more systematic approach, which was to create functionality first, and then when I feel like I have enough functionality for this, then if need be, if the users are requesting for a GUI, if they really want a visually represented data for this application, I would then go ahead and create a GUI for that functionality. So this is it, guys. I hope you liked it. This is Watchtower. Thanks.